This is lesson 5-7, which is equivalent algebraic expressions. This is the last lesson in module 5, so it's going to build upon everything we've been looking at so far. Let's go. Loading slowly. All right. Use properties to identify equivalent expressions. So equivalent expressions are expressions that have the same value, or in other words, they are equivalent. Algebraic expressions are equivalent when they have the same value no matter what value is substituted for the variables. You can write an equivalent expression by applying the properties of operations to an expression. So what they're saying is, like, sometimes they tell you x equals 4 and y equals 7 or whatever, but it needs to be that x can be whatever it is. Like, it can be 4, it can be 9, it can be 3,500,000 million billion, and the other expression that we're comparing it to needs to be equivalent when x is whatever it is, or y, or whatever the variables are. So this is the commutative property, and we've got the definition here. The order in which numbers are added or multiplied does not change the sum or product. So you can do 7 plus 9 or 9 plus 7. They're the same no matter which order you add them in, and same goes for multiplying. 8 times 4 is the same as 4 times 8. And that works for variables as well. A plus b equals b plus a, or a times b equals b times a. It doesn't matter what order as long as you do the calculation correctly. The associative property is the order in which numbers are grouped when added or multiplied does not change the sum or product. So same thing as above, only this time we have some groupings here. So in this case, if we have 4 plus 7 in parentheses, and then we've got 3 plus that outside, it's the same thing as adding if 3 plus 4 are in parentheses and the 7 is added on the outside. And that's true for the multiplication as well, and for the variables as well. This is like only true if addition is the only operation that's happening. If there's like minuses in here, or it's like other stuff we might be dealing with order of operations, then this does get changed. But if you're only adding, or if you're only multiplying, it doesn't matter what order they go in, even if they are grouped like this. And that's for adding and multiplying. And then the distributive property is what we worked on in the last lesson, 5-6. This is to multiply a sum by a number, multiply each addend by the number outside the parentheses. And so this is just reminding you how to distribute this out. So if you have 2 outside the parentheses of 7 plus 9, that's the same as 2 times 7 plus 2 times 9. And then it works here with subtraction as well. If you have 4 times 5 minus 2, that's the same as 4 times 5 minus 4 times 2. And that is true with these variable situations over here as well. And we've also got the identity property, which says the sum of an addend and 0 is the addend. The product of a factor and 1 is the factor. So if we are going 13 plus 0, then that's obviously just going to be 13. And so the addend, meaning 13 is the addend in this situation here. So anything plus 0 is just what it was in the first place. And then with multiplication, anything times 1 is just going to stay what it was in the first place. So 7 times 1 is 7. A times 1 is A. So a lot of these things are things that you already know. It's just giving you terminology and words for them. So just keep that in mind. We're going to go and try to use these properties as well. So here it wants you to drag each equation into the appropriate bin that describes the property it demonstrates. And so now you're not going to be dragging on your page, you're going to be sorting, and so you should probably write them out. I'm going to actually have you do that yourself. I'm not going to show you that. I want you to do it, and I will check that when I check your homework and make sure that you have gotten these in the correct places. So if you need to refer back to what we were just looking at to help you with that, go for it, and then just try and sort it into these 4. Here we are going to watch this real quick, and you can see how they played out for you.
You can determine whether the expressions 4 times the quantity 2x plus 3 plus 5 and the quantity 4x plus 3 plus 5 are equivalent by using properties of operations. Begin by using properties to simplify the first expression. Apply the distributive property to eliminate the parentheses. 4 times the quantity 2x plus 3 becomes 8x plus 12. Then use the associative property to group and combine the like terms 12 and 5. The first expression simplifies to 8x plus 17. Now use properties to simplify the second expression. Apply the associative property to group the like terms 3 and 5. Then add. The quantity 4x plus 3 plus 5 simplifies to 4x plus 8. Use the simplified forms of the expressions to draw a conclusion. The simplified forms have different terms. The expressions are not equivalent. Now consider a different pair of expressions, 8 plus 3n plus 2 and 3 times the quantity n plus 1 plus 7. Once again, start by using properties of operations to simplify the first expression. Apply the commutative property to change the order of the terms. Rewrite the expression as 3n plus 8 plus 2, and then use the associative property to group 8 and 2. Simplify the expression to 3n plus 10. Next, simplify the second expression. Apply the distributive property to rewrite 3 times the quantity n plus 1 as 3n plus 3. Then use the associative property to group 3 and 7. Simplify the expression to 3n plus 10. Use the simplified forms of the expressions to draw a conclusion. The simplified forms have the same terms. The expressions are equivalent.
Wow! All right, sorry I didn't hit the sound right at the beginning of that video, but you get the idea. All right, so I'm not going to talk about it. I'm just going to say something else. So a lot of us do these things automatically, and we're not thinking, oh, this is the commutative property, this is the associative property. We're not really thinking that, but you just know that if you have a 3 and a 7 that are added together, like you kind of just naturally will do that. That's okay. That's totally fine. There's not going to be something on the test that is specifically asking you to identify which property is this. You may have to do that in future classes, in 7th grade and in especially in your algebra classes. But for us in 6th grade right now, that is not necessary. But it is important to understand that they're true. So like it is important to know that you can add in any order and you'll still get the same sum. You can multiply in any order and you'll still get the same product. Like those, it's important to know that, but it's not required right now that you have the names of those properties completely memorized. It may be helpful because you probably will need to know that later. But I just wanted to say that. All right, next, let's look at an example. We're going to identify equivalent expressions. So we're going to use the properties of operations to determine whether or not 3 times x plus 7 plus 2 and 5 plus 3 times x plus 6 are equivalent. So in order to do that, they're going to have us simplify the first expression. They're telling you which property it is using in order to do that. So they have changed this version of it here to say 3x plus 21 plus 2. And they did that by going 3 times x, they're distributing, is 3x. And then 3 times 7 is 21. And then that plus 2 is just still chilling there. Then they are having you add these together, which then simplifies down to the final simplified version is 3x plus 23, because 21 plus 2 is 23. All right, and then we're going to look at the second expression and bring that down to its simplified form as well. And so this time we've got 5 plus 3x plus 6. And so they're writing this out as 5 plus, they kept that the same, 3x, 3 times x is 3x, and then 3 times 6 is 18. So they use the distributive property there to write it that way. Then they are moving stuff around to a different order just so that the 3x is out front again. So now we're left with 3x plus 18 plus 5. And then once they add those together, they get 3x plus 23. Does that mean they are equivalent? Well, let's find out. Wow. Okay, and they were nice here and they told us what the first expression was in case you forgot. All right. Okay, we're going to talk about that. You do the check and then let's move on. Let's use substitution to identify equivalent expressions this time. So this is going to not be those properties that we were talking about. This is a little bit different here. And so we have another little video that's going to show you how to do it with substitution. Here we go.
Determine whether y plus y plus y and 3y are equivalent expressions. One way to determine whether two expressions are equivalent is by using substitution. Begin by evaluating the expressions for the same value of the variable. Choose a number, 0, and substitute it for the variable in the first expression. Then simplify. 0 plus 0 plus 0 is 0. Then repeat for the second expression. 3 times 0 is also 0. When y equals 0, the expressions have the same value. If substituting one value for the variable indicates that the expressions are equivalent, repeat the process with a second value of the variable. Choose a second number, such as 5, and substitute it for the variable in the first expression. 5 plus 5 plus 5 is 15. Repeat for the second expression. 3 times 5 is also 15. When y equals 5, the expressions have the same value. Next, draw a conclusion about the expressions. If the substitution shows that the expressions have the same value for more than one value of the variable, you can conclude that the expressions appear to be equivalent. Now consider a different pair of expressions, 5 times the quantity x plus 4 and 5x plus 4. Start by evaluating the expressions for the same value of the variable. Choose a number, 0, and substitute it for the variable in the first expression. Follow the order of operations to simplify. 5 times the quantity 0 plus 4 simplifies to 20. Repeat for the second expression. 5 times 0 plus 4 simplifies to 4. When x equals 0, the expressions have different values. Next, draw a conclusion about the expressions. If the substitution shows that the expressions have different values for the same value of the variable, you can conclude that the expressions are not equivalent.
All right, you may have noticed that it said in the ones where it appeared to be equivalent that they specifically didn't say they're definitely equivalent. I'm talking about the first example, not this one that's not equivalent. Sometimes two substitutions is not enough and you might just get lucky and happen to get two where they are equivalent. But for the most part, it is going to be okay to just use two. So just keep that in mind, especially once you start dealing with multiple variables and things like that. You may find that you just accidentally got lucky and had a coincidence. I just wanted to point that out. Yeah, but definitely use more than one value to determine equivalency. 2 is usually good. All right, let's try it out in example 2. We are going to see if 2x plus x and 4x are equivalent. So let's start with x equaling 0, 1, and 2, and we're going to substitute these in and compare them. So first we've got our expressions written out, and then we're going to try it with 0 first. 2 times 0 plus 0 plus 0 equals 0. And then 4 times 0 equals 0. So far they are equivalent. Let's try it with 1. 2 times 1 plus 1 equals 4. 4 times 1 equals 4. So far they are also still equivalent, and they just want you to try it with 2 as well. 2 times 2 plus 2 is 8. This is when x equals 2. 4 times 2 equals 8. So this is 3 different substitutions here, and so we can probably conclude that these are going to be equivalent. So that is just something to consider. And yeah, use easy numbers for sure. Try the check and let me know if your expressions are equivalent using substitution. All right, here's another example. Same thing using substitution again, but we've got a little bit more of a complex set of expressions here. We have some fractions and some exponents here. So first write out the expressions. It's good to write them. I kind of like doing it in this list form where one's on one side, one's on the other, and then they want us to use 0, 1, and 2 again. These are the easiest values to test out. So if x equals 0, then we can plug in 0 or substitute 0 in here, and we come up with the answer of 1/2. And if we plug in or substitute the 0 in on this expression on the right side, we also end up with 1/2. Okay, so far they are equivalent. If we try it with x equals 1, we end up on the left side with plugging in these 1's here, we end up with a 2 as our answer. On the right side, our second expression, if we plug the 1's in, we end up with 3. So we already know they're not equivalent because 2 is not the same as 3. So you honestly could stop there, but the problem actually wants you to do the 2 as well. And so if you were to do that, you could do this. I'm never gonna, you don't need to. If you find that it's not equivalent in 2 substitutions, you could stop there. That's enough for me, but they just wanted to show you one more time on that. Okay, so try that again. It's a different problem here. And then combining like terms. This is something we've already talked about a little bit in earlier in this module, but this is something that is helpful in order to bring our expressions down to simplest form. And so simplest form, if there are no variables, would be the solution to the expression. But if there are variables, you'll still have variables in your simplest form. So an expression is in its simplest form if it has no like terms and no parentheses. So you shouldn't have any parentheses left, and you shouldn't have any like terms left because you're going to be combining those. You can use the structure of an algebraic expression to combine like terms and write it in simplest form. When you have an expression with only constants, such as 5 plus 2, you can combine these terms for a result of 7. In other words, you add them together. Sometimes when you have an expression with like terms such as 3x and 5x, which means 3 groups of x plus 5 groups of x, you can combine like terms for a result of 8x. We still don't know what x is, so we leave that in there in our simplest terms, simplest form. All right, you also can model this with your algebra tiles. I'm going to skip this video for the purposes of this, but if you're interested in it, it is available on Reveal Math Online. All right, you also can use the distributive property to combine like terms, and this allows you to simplify by adding or subtracting the coefficients of the terms. So let's say you start with 3x plus 5x. You can pull this out, you could factor it out to x times 3 plus 5, which is the same as x times 8, and then we don't usually write x8, we would write 8x. All right, I'm going to talk about that. So let's combine like terms in example 4 here. Let's simplify 2x plus 5 plus 4x minus 3. This is the slowest ever. Sorry. Okay, so first write the expression 2x plus 5 plus 4x minus 2. And then we can change that into 2x plus 4x plus 5 minus 2. And that is the commutative property. These first 3 terms are being added. They can be added in any order. And then we want to keep the subtraction at the end. because just because it's not an addition. So doing this means that our like terms are now next to each other. That's why they did that. So then they're factoring this out. You can go x times 2 plus 4, and then we have plus 5 minus 2. You don't have to do it this way. You can just be like, oh, 2x plus 4x, that's 6x. If you can see that, you can do it that way. That's fine. But this step in between will still result in 6x, and our 5 and our 2 are still there, not touched. Then we can combine our like terms here. 5 minus 2 is 3. So we're now left with 6x plus 3. And so there are no more like terms here, and so that means this is the simplest form here. I don't want to talk about that. All right, you try it. You combine the like terms given to you there, and you don't have to do every single step. Like, you don't need to factor it. If you can just see how they will go together, go ahead and put them together that way. All right, let's do another combined like terms example. Eventually, once it loads. This time we've got 5x squared plus 2x plus 2 plus x squared plus 6. And so what I really actually don't like about the way this book is doing this is I think it's important. Oh, just kidding. It just did it right here. I was going to say have it, you need to kind of determine which ones are the like terms. So our x squared terms, that would be this one and this one. And then our x terms, there's only one of those. And then our constants go like this. That's usually the first step you should do, is actually identify what the like terms even are. So that is one way to do it, to sort it. Another way is just to look at it and have that in your brain, whatever works for you. Then you can simplify it from there. So we have our expression. We know our like terms, so we're reordering that. So we have our x squared terms that are similar together, and then we have our lone x term, and then our constants are together. That way they're all right next to each other in a row. Then you can combine them. So if we have 5x squared plus 1 more x squared, that's going to be 6x squared. Nothing to combine with the 2x, but we can go 6 plus 2 and get our 8. And so that is the expression there. Blah, 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 blah. You do that yourself. And then typically the way you would write the expression like that, notice how the one with the exponent was first. It's kind of like the order of operations. They show you the 5x squared or whatever it was, 6x squared. The exponent is first because of PEMDAS. And then the next one was 2x, that's multiplying. And then the last one was just the constant, usually goes at the end. All right, and then last one here. This is our last situation. We're going to apply properties to write equivalent expressions. So this is, instead of comparing them, we're just going to write them out. So when you simplify an expression, you can apply properties and combine like terms to write equivalent expressions. So if we have 3 times 4x plus 1 plus 2x squared plus x, we can change that here to 12x. That's 3 times 4x plus 3, which is 3 times 1 right here, plus 2x squared, which is already there, plus x, which was also already there. And then we're reordering these to be 2x squared plus 12x plus x plus 3. And that does actually simplify down a little bit more because we're going to combine our 12x plus 1x here into 13x. So we end up with 2x squared plus 13x plus 3, which is equivalent to what we originally started with. Last example, write equivalent expressions. We're going to simplify this big old thing right here. 1/2 times 2x squared plus 1/2 plus 2/5 x squared plus 7. That is quite crazy. Sometimes that is necessary. So we're going to practice with it. So here we go. Loading. First, write the expression. Well, they already did that for us. Thanks. All right. Then we are using the distributive property here to factor this out. So we've got x squared. That comes from dividing this 2 in half or multiplying 2 by 1/2. That leaves us with just x squared instead of 2x squared. And then plus 1/4. That 1/4 comes from 1/2 times 1/2. And then this stuff was all already there. so we leave that alone. Then we can reorder these things. So we have x squared plus 2/5 x squared plus 1/4 plus 7. So just reordering those so that our like terms are next to each other. And then we can combine those like terms, which means we have 1 and 2/5 x squared, so that's x squared plus 2/5 x squared, plus 7 and 1/4. So yeah, we did end up with some mixed numbers in this. That is fine. And so we don't need this slide. We already did that. Okay. Last check. Try it out. Apologies, this video is a little longer than usual, but I didn't want to split it in half. I think you could handle it. So do your best on the checks. We will practice with a little bit more during class.